Hello, here we're going to continue our look at 8.5, factoring by grouping. In the first video, we focused on the distributive property to factor, right, which was simply the opposite of, instead of distributing the 3 in, we were going to take the 3 out. And we did the first example, but we didn't cover example 2. So today we're going to focus on what's called factoring by grouping. All right. So one way that factoring by grouping is going to be different is that you will see that it has 4 terms. There's 2 terms, and there's 2 terms. So when you are instructed to factor by grouping, you must first group 2 and 2, and then look for the GCF of each. Alright, so let's do that. I've grouped up the first 2 and the second 2. I need to pull out the GCF of both. So let's focus on the first 2 first. I see that there's a 6 and a 3, so they're both divisible by 3. I see that they both have an a to give, but they don't both have either an x or a y. So the greatest common factor of the first 2 terms is a 3a, leaving on the inside a 2x plus y. And if this confuses you, how we just took the GCF out, you need to go back and rewatch yesterday's video, 8.5 part 1, because it was all about having 2 terms and pulling out your greatest common factor. And you can still double check this by making sure that if you multiplied 3a back into both of those, that you get the same answer that you started with, which in this case we do. Now, let's go to the second group. There's a 2, but the other one doesn't have a number, so I'm not going to be taking that out. Instead, I recognize they both have a b. This sign's always going to match down below. That's something exclusive to factoring by grouping. So let's go ahead and carry that sign down. So then we've got a b that was our greatest common factor, leaving us left over with 2x plus y. All right, so you must group 2 and 2 and look for the GCF of each. We have done that. Now here's how you know that factoring by grouping is on the right track. Notice that this is 2x plus y. Notice that this piece is 2x plus y. That's kind of the halfway spot. If those don't match, you have messed something up here. You've unsuccessfully pulled out a GCF or made some type of mistake. If those 2 terms match, though, you're good to move on to the next phase. Then, your GCFs form a group, and the matching, remember we just checked that they matched, remainders form the other group. So here's what I'll do. I'm going to write out 2 parentheses here. My GCFs form one group, so I'll have 3a plus b as one group, and then the term that matched forms the other group, 2x plus y. And you're essentially picking either one of those. It doesn't matter which one of those you pick. Factoring by grouping answers, though, however, will never get a squared right here. It's very tempting because people see 2x plus y, another 2x plus y, so they're very tempted to put a squared. Don't do it. That squared will not be there because this plus sign is stopping these from multiplying. These 2 terms are not multiplying together because they are separated by a plus sign. If you put the squared there on factoring by grouping, you're wrong every single time. Don't do it. Now, the reason that this works is just the distributive property. The reason that this turns back into the original concept is because what we would do to go back and find the original answer, the original statement, I'm going to write this again, is we do FOIL, right? And FOIL involves taking the 3a there and there, okay? That's happening right here. 3a times both the 2x and the y. And then we would take the b, and the b would multiply there and there. There's it happening. The b multiplying by the 2x and the y. So that's why this all sorts out. And if you don't believe it, follow the FOIL lines. So when I do this one, we get 6ax. When I follow this one, get plus 3ay. When I follow this one, I get 2bx. And when I follow this one, I get plus by. And if you look, that is the original term that we started with. Now the good news is that this one's a little bit more tricky than the ones we'll spend our time on because it had multiple variables. We really won't focus on ones with multiple variables too much. I just wanted to start us off with one to where you could see all the different pieces happening. All right, so we need to find the ones that say factoring by grouping or determine the ones that have 4 terms. And these ones down here, they tell us factoring by grouping. And remember that involves us looking at it from the perspective of 2 and 2. Let's find the GCF of both. This first one, they both have x's to give. So I'm going to pull out an x. And when I do that, I get x plus 2. For the second set, this sign drops down. You might be looking here and say, hey, there's no GCFs among those 2 terms. But I need to pull out something. Whenever that happens, pull out a 1. Which 1 leaves it the exact same. We can do the halfway point check. We'll see, did we get the same term twice? We did. So that's what's told us we've done everything correct so far. Now we're ready to write out our final answer. And the way that works, your GCFs form a group. And then you take one of your groups, not both. So it's just x plus 2. Do not put the squared there. If you put the squared there because you saw x plus 2, you're wrong every time. This plus sign stops them from multiplying, so they will not become squared. So this is here the final answer. After we do a few more of these, I think you'll start to get more and more comfortable with them. They seem weird at first, but once you do some, they're not so bad. Let's move to the next one. The key is to recognize you have to group them 2 and 2. So when we do this, the GCF of the first one, they're both divisible by 2. They're both divisible by a y. And we're left over with 3y minus 2. This is another instance where the second 2 don't have any common GCFs. We'll roll that plus sign down. They don't have any common GCFs, so that means I must pull out a 1. Halfway check. 3y minus 2 matches with 3y minus 2. So we're good to form our answer. The 2 GCFs form a group. 2y plus 1. Our matching pairs form a group. And now it's complete. Let's go ahead and do one more here below, number 17, that has a single variable before we try some of the double variables. I see 4 terms. I'm factoring by grouping. So I'll go 2 and 2. GCF of the first 2 is 3a, leaving us with 4a plus 1. Remember yesterday we talked about anytime we divide a term by itself, by the GCF, it is 1. Now, for the second 2, this sign rolls down because we're going to need to take out a negative. We're going to be pulling out a negative here, and the GCF between -8 and -2 is -2, which will turn into a +4 and a +1, because -2 divided by -2 is a +1. And we can now check. 4a plus 1, 4a plus 1, those match. If you didn't pull out this negative sign, you would not have had matching red terms here, and that would have told you that something is wrong. So then for the final answer, your GCFs form a group, so 3a minus 2. And then the matching terms create one group. Don't put the squared there. If you put the squared there, you are wrong. That's factoring by grouping. First 2, second 2, pull out the GCF for both. Then the GCFs form a group, and the group that you had twice forms a group. Some of the remaining ones are a little more tricky because of the variables. We did one at the start of today's lesson, so you can rewatch that one if you would like to see another one of those. Also, if you had a hard time on 13, 14, and 17, I encourage you to rewind this video before I do them. You try to complete them, see where you get stuck, and then watch the video for help. Let's talk about where we could use this. The area of a rectangular swimming pool is given by the equation area is equal to 12w minus w squared, where w is the width of one side of the pool. We're going to write an expression for the other side of the pool. And we know that area is equal to length times width. And they tell us that where w is the width of one side. So we have a w here. And the overall area is 12w minus w squared. So we're trying to figure out, well, what's that length? In order to do that, we need to take, because we're trying to solve for the length, we need to take both sides and divide it by width. So if I go through here and I try to divide both of these by a w, which I can, because they have a GCF, we'll get 12 minus w. So this w's right there. This now tells us that that question mark, the other side length, is 12 minus w. And that works because w times 12 minus w, when I distribute, gives us 12w minus w squared, which was the initial area. So this is factoring by grouping. Now this problem here at the bottom was more so just factoring using yesterday's method with reverse distributive property, but it was good to see either way. I encourage you to watch through this video again a second time if you have any confusion on factoring by grouping. It can be a little tricky for students until they've tried it several times.